Okay. This is Algebra 1. This is our, what is this? 1 through 55 review, part 1. The year is 2021. This is second hour class. We're excited to go. All right. First question says, identify the independent and dependent variables in this situation. The amount of electricity used for air conditioning in homes increases as the temperature is increased. Okay? So there has to be something that doesn't depend upon anything else. It's completely independent. Does anybody know what is completely independent? The temperature outside. Does the temperature outside care about your house? Does it care about the amount of electricity that you're going to use? Does it care about what type of air conditioner you have? Do you have any control over the temperature outside? Therefore, it is independent. Okay? It is an independent variable. And I don't know if that's going to let me write on it or not. It might take a minute. My smart board's been rather stupid today. Anyway, so temperature is independent. Okay? What is your home dependent upon? Is it dependent upon anything? Because look, there's an option for neither independent or dependent, isn't there? All right, I'm going to try something here. Sometimes this thing just needs unplugged and plugged back in. There we go. Watch it freak out a little bit. Let's try it now. No? All right. Okay, and I may have to do some stuff from over here. All right. Let's see. And it doesn't look like, is there no answers listed in this? You got them all right? Okay. So Maggie, we're going to talk to you then. You've got our answer sheet here. Okay, maybe it's, oh, okay, so I think it's listed kind of like this. The air conditioning is independent. Is that right? Okay, so air conditioning is an independent variable. Amount of electricity used is dependent upon what? How much you run the air conditioner, right?
The air conditioning is actually neither.
Oh, okay. See, that makes more sense to me, that the air conditioning would be neither independent or dependent. But the amount of electricity is dependent, right?
Yeah.
It's dependent upon the temperature outside, because as the temperature increases, what are we going to run more? We're going to run the AC more, right? So as the temperature increases, as the independent variable increases, so does the dependent, right? Okay, so amount of electricity is definitely dependent. What was homes? Neither, again, right? Your house isn't dependent upon the temperature that's outside, right? Your home is your home. Your air conditioner is your air conditioner. The temperature outside is independent. Do we have all of that correct now? Okay. So I don't know. Hey, at least we're here. Or at least we're working. This is operational now. Okay, so you want to go through it again? Okay. All right. So number 2, determine if the sequence could be arithmetic. So our answer is no, it can't be arithmetic. All right, if so, give the common difference. If it's an arithmetic sequence, just enter the value of the common difference. If it's not, just enter no. All right, so how did you determine that the answer was no? Okay, so you tried to find the difference of the numbers. What's the difference between 7 and 4? 3. What's the difference between 4 and 2? What's the difference between 2 and -1? 3. What's the difference between -1 and 5? Right, so there's no common difference here, right? Our answer is, for whatever reason, I can move the board up and down. I just can't write on it. All right, so with that in mind, when we go, and I'm going to try this again, because this should work. Okay, but the bad part about the video on this is going to be that we have to listen, right? I can't go based upon, all you're going to see in the video is me scrolling up and down, right? You won't see anything that wasn't marked on the board. Okay, let's try this. Still nothing. All right. I mean, I could write on the whiteboard over here and you would see it in class. You're just not going to see it in the video. Okay. Which doesn't work for somebody like Braden, who is out kind of depending upon the video. So that's why I'm trying to get it to work. All right, so we'll just have to listen closely. It says a book costs $40. It goes on sale for $36. What is the percent decrease? I'm going to try this. This might work instead. Maybe. Okay, so let's try this. There we go. All right, let's write on this. Clap, 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 clap. Okay. All right, so it was $40, and now it's $36. We want to know what the percent, was it just percent change? All right, what's the formula for this? New minus original over original. And we are still having some trouble with this. Okay, what is the new number? 36. Okay, what was the original number? All right, and what I'm seeing a lot of students do, you might get the numerator right. You're getting the 36 minus 40, but then you're dividing it by 36 instead of 40. Right? It is new minus original over original. The original stays the same. Now we are getting better, but we are still, some people are still making some mistakes. So what is 36 minus 40? Negative 4 over 40, right? So it would be a negative 0.10 or negative 10%. So it is a, now what they're looking for here is what is the percent change? Do I need the negative? No, it's just a 10% change. All right, let me see if I can come back over here. Okay. What is the percent? Because it already tells you what is the percent of decrease. So all I want here is 10%. Okay? Notice how none of these say negative 10%. Okay? So be careful with that. All right, number 4. This table shows the number of swimmers in the ocean that at a given time. We want to find the rate of change for each time period, during which period did the number of swimmers increase at the fastest rate. We've had a question similar to this on a test, at the very end of a test, and we did really poorly with it. There was a graph of days of the week where we needed to see numbers increase. And it was like Monday, Tuesday, Wednesday, Thursday, Friday, between which 2 days had the greatest change or increase, right? And we really struggled with that. So hopefully we're doing a little bit better here. All right, find the rate of change for each time period. Okay, so from 10:30 to 12:30, right, how much am I going up? 14. Okay, do you guys have this test pulled up? Okay, so what I'm going to do is I'm going to pull this up over here. Okay, so let's see, it was 10:30 to 12:30, right? And what were the numbers? If you have it pulled up, don't guess at it. Don't try to memorize it. You've got the test pulled up, right? All right, so tell me what is under 10:30? 41. What's under 12:30? 55. Okay, what's the next time? 1:30 p.m. Okay? 64. 70. Is 5:30 the last one? 80. Okay? All right. So I noticed a couple of things here that I don't know if you notice or not. Notice from 10:30 to 12:30. Does anybody see what's skipped in there? There's no 11:30, right? So this is a difference over 2 hours, right? Okay. So it increases 14 people over 2 hours. So it increases 7 people for 1 hour, right? Its rate of change from 10:30 to 12:30 is 7. Does that make sense? Okay. Now from 12:30 to 1:30, that's just 1 hour, correct? So what's the number from 55 to 64? 9. So that's 9p over 1 hour, so it's just, it stays the same. Okay? Would we say that from 12:30 to 1:30 that there was a higher rate of change than from 10:30 to 12:30? Yeah. Okay? Now, notice again, from 1:30 to 3:30, how many hours am I talking about? 1:30 to 3:30 is 6 hours? Okay, it's 2 hours. What do you need, Braden? Okay. All right, so we're increasing just 6 people, right? Okay, how many people per hour? 3 people for 1 hour. Okay, what happened to our rate of change? It dropped. All right, now let's go from 3:30 to 5:30. How many hours are taking place there? 2, and it's what, 10? 10 people. So what's my rate of change? 5 people per 1 hour. Okay, so I want to come back to our question. When is the greatest rate of change? From what hour to what hour? 12:30 to 1:30, there was an average rate of change. There was an increase of 9 people per hour, right? Okay. Okay. Let's come back to the question, see exactly what it's asking. Find the rate of change for each time period during which time period did the number of swimmers increase at the fastest rate. We should get 12:30 to 1:30. 12:30 to 1:30 is correct. Did anybody get that wrong because they didn't pay attention to the number of hours in between? Okay, so did we learn something here? Okay, is that an easy one to get fixed? Sure. So pay attention to those little things. Okay, where the purpose there is to trip you up. Okay, to see how observant you are. All right, let's keep going here. All right, we want to solve for x. Oh, we've done a dozen of these. We've seen this on tests all over the place. Make sure we're paying attention here. What's the first thing I want to do? Distribute the negative. Very good. All right, we're going to distribute this negative, and I can't show it. All right, so you guys are going to tell me what that problem says, and we're going to write it up. So I think x minus x plus, like that? Okay. All right, so you said distribute this negative to each of these terms. So I should be writing 3x what? Minus x minus 3 plus 5 equals 16. What is our goal here? Solve for x, which means I need to isolate x. But before I do that, here I'm going to combine like terms, correct? 3x minus x is good, 2x, negative 3 plus 5. We're still kind of struggle with negatives and positives. It's 2, positive 2. Okay? And if you've got a calculator, can we check that? Can we make sure that we get that right? Can I write negative 3 plus 5, hit enter, get 2? Okay, plus 2 equals 16. Ms. Akins, what do I do next? We want to solve for x. So we want to move everything else over to the other side. Isolate x, absolutely, that's what we want to do. But right now, with x, there is a 2 here and a 2 here, and I need to move them over. Okay? And in order to move things across the equal sign, I have to do the opposite of what is happening. And I actually start with the opposite of the order of operations. So instead of working exponents, multiplication, division, I actually start with addition and subtraction. So is there any addition on the left-hand side of the equation? All right, what's the opposite of addition? So how do I move this 2? Subtract it from both sides. Okay, so I have 2x. What is 16 minus 2, Bailey? Yep, 16 minus 2. Yep. Okay, did you say it and I just didn't hear it? Yeah. I'm pretty hard of hearing, so you really have to speak up. All right, now, what is happening here, Bailey, between 2 and x? Is that addition, subtraction, multiplication, or division? How do I undo multiplication? Division. So I'm going to divide by 2 on both sides. So x equals, what's 14 divided by 2? 7. Okay, so we should get x equals 7 there. And I want to type in x equals 7, right? Yeah, if you just wrote 7, right, it's going to count it as wrong.
Oh, I said it like that. I didn't distribute like the negative. I kept plus there.
Right, we need x equals 7. Okay, now this question right here is still causing us a lot of problems when we have multiple variables in a question and it wants us to solve for only one of them. Okay, so 3p plus 9t equals 8, and we want to solve for p. All right, 3p plus 9t equals 8, solve for p. So we will want an answer that says p equals. Okay, good. Subtract 9t. Okay, are those like terms? Are 8 and negative 9t like terms? So whenever I write this up again, I'm writing 3p equals what? 8 minus 9t. Okay, because they're not like terms, I can't, it's still subtracted over there, but I'm not reducing it at all. Okay, now I'm just trying to solve for p, not 3p. So Sanchez, how do I get that 3 moved over? What's happening between the 3 and the p? Are they adding, multiplying, dividing, subtracting? Yeah. What did you say? Yeah? Uh-huh. How? Divide by 3, right? Okay, what do I divide by 3 on the right-hand side? It's actually the entire thing. So when it's addition and subtraction, I'm either going to add or subtract from something specific, right? A like term. But when it comes to multiplication and division across, I actually multiply or divide the entire other side. Does that make sense? Okay. So what I'm getting is p equals, and I can either write it like this, where I would maybe write 8 minus 9t divided by 3, like that, so that I'm seeing that this is the entire numerator divided by the denominator. Okay, and I would have to have parentheses around the entire top portion. Okay, if you don't have parentheses around this, what your calculator and what you're telling me is that p equals 8 minus 9t divided by 3. All you're saying is that the last thing is being divided by 3, which is not what we want. Well, okay, so you said 8 minus 3t, correct? Okay, the 3t is not wrong, but if you're going to do that, it needs to be 8/3 minus 3t. Because the 8 is also being divided by 3. Do you understand? This part right here, this top portion is what you had. Did you have parentheses around it? Okay. Then I would say, because there's so many kind of different ways that we could type this in, that whenever it was set up in the answer key and you have to type it in, you can't type in every iteration. So whenever it gets to this point on the test, I would have to look through and see if you have an acceptable answer and then give you credit later. Okay? Which I'm not going to do that for the reviews, okay, because we're going to talk about it here. Okay? Do we understand this?
So which one can we write down?
Either one of these two. And you can have the order different here. So like you could also have written this as p equals negative 3t plus 8/3. You could have had it written like that. Does that make sense? So I can flip the order here down at the bottom. Either one of those two, or I guess 3 if you want to consider it. Do we understand this question? Okay, because we're still really struggling. If I have an equation that has multiple variables and I want to solve for one, all I'm doing is picking out that variable and then moving everything else across. All the steps remain the same. Let's see. So just tell me. That way I'm not flipping back and forth, I guess. All right, so it's what, 9y minus y equals equals 40?
Yes.
Solve for y. Okay, what's 9y minus y? Can I simplify that? 8y equals 40. Now what? Divide by 8. Okay, y equals 5. Right, that should be easy. We should be able to do that, correct? Okay, combine like terms, isolate the variable. All right. Okay. It's the beauty of doing this. Okay. I have to check and make sure what time we get out of here so I know when we'd have to find a good stopping point. 18. Okay, we've got about 6 minutes. We might be able to cover one or two more. Okay. Let's take a look. Where are we at? 7. Okay. Stop that. All right, 8. All right, we really want to listen up on question 8 because how many parts? It's got 2 parts, right? Okay. And these are questions that we're struggling with. These are questions that we are SMART goal testing. These are questions that you're going to get evaluate tested. These are questions that you're going to get EOC tested on. So we need to improve our skills at graphing linear equations, okay, and understanding things like slopes and y-intercepts. Okay, the equation y equals 40x describes how far from home Dina is as she drives from Dallas to Miami. We're going to let x represent the number of hours, let y represent the number of miles. How far from home is Dina in 12 hours? So let's come over here. Okay, y equals 40x. And then tell me what these variables mean. What is y?
Miles.
Miles. It is our dependent variable. Okay? And x is hours. So the number of hours determines how many miles I have. So if I want to find miles, what am I solving for? X or y?
Y.
I'm solving for y. So if they tell me it's 12 hours, where do I plug 12 in at?
X.
So I plug it in right here. What is 40 times 12? 480. And that's in miles, correct?
I put 480. Maybe I need to put Y equals 400.
No. Did you put miles? Okay. Because if I asked you, how far is it from here to Denver, Colorado? And you said 1,200. 1,200 what? Right? 1,200 kilometers, 1,200 miles, 1,200 yards, right? Whenever it comes to real-world questions that involve labels, we need to include those labels or we will not get that question counted as correct. Okay? Yes? Yeah, MI will work. You can abbreviate miles. It may not have counted it as correct. But if you're going to abbreviate something, what should go at the end of that abbreviation? A dot. You know, so if it's MI, it's dot. If it's inches, it's dot. If it's feet, it's dot. Okay? Yards. Period. Okay? Does that make sense? All right. Let's look at the B portion. Graph the equation. Is it linear? So the equation was y equals 40x, right?
Yeah.
All right, let's come over here. If I was to graph this, okay, what is my y-axis representing? Y equals 40x, right?
Y is representing.
Y is miles. Miles. What is this? Hours. Okay? And the slope is what? What is my slope here? Y equals mx plus b. Let's come back to this. What is m? M is what? Slope. Okay? And slope is what? Rise over run, which means slope is always a fraction, right? So what is in for slope in my equation? 40. All right. What is the fraction for 40? 40 over 1. 40 miles over what? 40 miles over what? 1 hour. Okay? So we're going to have 1 hour, 2 hours, 3 hours, right? 1, 2, 3. We have a different set of scale down here. Now, because we're dealing with a really large number like 40, okay, we're going to say 40, 80, 120, okay? So I'm here, here, and there, right? And I could probably, I don't know, I may not be on the, I'm trying to do it like this. Now, before he takes off, right, or she or whoever is driving, right, before they have taken off, how many miles down the road are they? 0. So notice that the y-intercept here is what? 0, because there's no y-intercept listed, right? There's nothing there. Okay. Is this linear? Yes, it is linear, but you're going to show me a graph. Okay, you're going to graph it. You're going to prove that it's linear. All right, that's a good place to stop. We will pick up with question number 9 tomorrow. You guys have a great day. Okay? All right.